I'm an entomologist with the Department of Plant and Environmental Protection Sciences at CETA, UH-Manoa. I work primarily on biological control of invasive pests and other IPM options. And specifically today, going to be talking about use of a pheromone in coffee berry borer management, specifically a repellent pheromone, which is now labeled for use in Hawaii on a special local needs label. So I'll give some background into how this works, the data we have, and then at the end show you the final registration with Hawaii Department of Agriculture and Biosecurity, as they're now known. Oops. All right, so let me just get this clever thing going here. So this is an image taken from a paper published in the Journal of Pest Science last year, where they talk about this pheromone called Verbenone. And it's they actually titled the paper "Universal Bark Beetle Repellent?" ? That's said because it does deter, it repels a bunch of different species of bark beetles. Turns out, including coffee berry borer and a couple of others in that same genus. See a little asterisk there. To be more specific, it's not necessarily always a repellent. It can also be an inhibitor. It can inhibit the beetle's ability to find a plant to go and attack. So this was first found out in pine or spruce bark beetles, both in the US and Europe, in the Ips genus. And they found that what happens is beetles will come and find a tree, usually males, and they'll bore into the tree. The tree starts to try and defend itself by pushing out resins. So the beetles need to have like a mass attack to overcome that. Once they have enough beetles, they're overcoming it. Once they've aggregated enough to reduce that effect, they don't want too many more arriving, so they want to deter them. So they release verbenone, this disaggregation pheromone. A pheromone, by the way, is a hormone that is airborne, right? So it's a product produced usually by a gland in an organism that causes some kind of a reaction in the same organism or others, in which case we call them other things, but let's just go with pheromones. In this particular case, it may be actually that this chemical is produced by bacteria living in the gut of the beetles, just by the way. But anyway, it works like a pheromone. Once they've released it, the attack of the tree stops, and they start to be quite effectively deterred from the tree in many cases. Turns out this happens in multiple species as well. If we just look at this is just a little illustration of that, right? So start off with the tree being attacked. You have a bunch of beetles arriving. Once enough have arrived, they start to prevent others from coming, right? So you don't get overcrowding. This also prevents other species from arriving and attacking the tree. So once the verbenone is being released, other species will be deterred and they don't come and attack after the initial intended attackers have been there. People have also looked at whether this compound verbenone influences natural enemies. Actually, it does nothing to them. It doesn't repel them. It doesn't attract them either. Which is a bit nice. If it did attract them, that would be very useful. But so this provides, and verbenone is extremely safe compound. It smells like wintergreen, like the stuff you get in Bengay, the stuff that's used for muscle inflammation and so on. And it's harmless to everything, pretty much. All right. An important thing that they found when working on this was that it does reduce beetle attacks substantially, but there's always some individuals not affected. There's some variability, and we'll see that in the data I'll be showing as we go along. It's not a fail-safe system. It can be circumvented by some, but it does significantly important things. Some years ago, we looked at verbenone, among other components, as potential repellents for black twig borer on coffee, and also acacia koa, because black twig borer was an issue in, well, both of those, probably still is. We just used regular verbenone that one can acquire from chemical providing companies, without any real consideration for which isomer it is. You get different isomers of chemicals, the physical arrangement of the molecule itself, and that can influence the properties of those compounds. Anyway, back then we found, if you look at the results over here, which one? A is black twig borer. We'd reduce the numbers caught in traps if we're repelling beetles from traps by about half for black tree borer and fairly substantially for others too. So that's some potential. But we looked at this initially for coffee berry borer. It didn't actually work. It just didn't seem to do anything until um, until this company ISCA Technologies in California, they started looking at it and they discovered that you have to have the correct isomer, which they in fact have now formulated into this product that they call SPLAT. The fact that I'm talking about this specific compound, doesn't mean I'm marketing for them or anything. Just they happen to be the one organization, the one company that have produced this product and are marketing it. They initially produced it for use on pines on the mainland. It's an interesting thing, SPLAT. SPLAT stands for Specialized Pheromone and Lure Application Technology. Clever little system that they make. You get this stuff, SPLAT, in it. It looks like a caulking gun applicator. You squeeze out blobs of it, like this little thing here. It looks like a little turd. And then once it's out and exposed, a bunch of the water inside evaporates, and then it forms a little crust. And then each of these little white dots represents the chemical that you actually want released into the environment, which it does slowly, as it's now in this matrix with a crusted edge. So that's slowly released over a period of can be anything from a couple of weeks to 6 months, which is pretty impressive, yeah. 6 months is an extreme case, and I think that they have one or two products. What we're talking about here is probably a 3-month effect that I'll show you in a while. But important, right? So they've got the right isomer, they have a controlled rate of release, and the release is adequately fast to have a significant effect. So let's have a look at what we did before actually labeling this. We started out working with Dole over here on Oahu. And then, so they have quite substantial areas of coffee, which is what you need for these kind of trials. You have to have large blocks where you make treatments within the blocks so that they don't influence neighboring blocks and they don't influence the controls for experimental reasons, right? So we'd set up these big plots. We'd go and treat them with SPLAT. And the way we did it was we'd go to every third tree within the row, within the plantation, and put a little blob onto it, a couple of grams, just in this metered caulking gun system, right? You just go and squeeze it out. It's very quick, very easy. And then after that, we'd go back and we'd assess CVB infestation, how many beetles were attacked, how many beetles we were catching in traps, how many beetles we were catching in traps outside of the orchard as well. And we had control blocks, of course, right? Untreated blocks, so we could make a comparison between those with verbenone and those without. And then we also wanted to make sure that we could get what we call a shutdown effect on traps. So, and this is what we did in the very first slide that I showed with any results, is you put out traps that are known to be highly attractive, in this case, baited with methanol lures, which, as you probably all know, are very attractive to CBB and other bark beetles. And then we go and we treat the trap with a blob of SPLAT and see if we can override, inhibit, as it were, the effect of the lure. And so we'd compare that with regular lures, right? And then at the same time as we were doing this, we were also looking, some colleagues over in the Forest Service were really interested in looking at using verbenone to deter beetles that can affect rapid or hair death. And they looked at multiple species very successfully, and then started looking in macadamia nut, and we're still doing that actually to look at developing a the repellent system, pushing beetles out and trapping them as they emerge. And it also seems to be working quite well. Let me talk about what we found, our results from coffee. These are different years, 2019, 2021. I'll show you 2020 in a bit, but there was a bit of an unfortunate situation, as you can imagine. We'd start doing these applications in April, which is relatively early in the season. We could have started a little earlier. But starting in April means we actually had some infestation to work with. What you see over here is over a period of a couple of months, April through June, and I think about the same in 2019. If you look, the percent of infested berries with CBB is on the vertical, the y-axis there. You'll see that the control plots those ones up there that I'm highlighting now, have substantially and significantly higher infestation than the plots where we put the Verbenone treatments. Both of these lines at the bottom are Verbenone treated. It's about 50 to 60% reduction in infestation overall, if you look at the average. We had a strange little situation over here towards the end of the 21 trial, which I'll talk about a bit later. It's kind of a strange thing that you have this sudden drop-off in percent infested. Usually that you'll get that if you have this, you have asynchronous blooming in coffee. So you'll have the initial fruit set and you'll get an increasing amounts of damage. But then if you get more and more fruit sets, so the proportion infested can drop, right? And that's kind of what happened there, curiously. I'll talk about that again in a bit. Overall, what we're showing here is 50 to 60% reduction just by making a single application of SPLAT. Near the beginning of the season, if we'd done it a bit earlier, you'd probably see even less in SPLAT, less CBB in the SPLAT treated plots. 2020 was a bit unfortunate because of COVID and so on. We got off to a really late start when we put in the treatments in May, by which time the infestation was pretty high, 60, 80% maybe. And still kind of had a statistically significant, but not ecologically useful, economically useful effect. Overall, still got a significant reduction in infestation over the season in the Verbenone treated ones. Not impressive, right? Because we got in so late, the infestation level was already so high. So these results, I think, are more significant in terms of what this product can do economically. This is what we found with the shutdown experiments. You're probably all familiar with these bottles that you can tin to traps and then bait with a little bit of methanol in a little container within, and then fluid at the bottom in which you then catch the beetles that come in. And you can see over here we put a little dollop of SPLAT Verb up on top, and this is to see if we can prevent beetles from coming to the trap compared with traps that don't have that little dollop of Verbenone up there. If you look at this graph, what you see is there's a dramatic impact on the average number of CBB caught per trap. This is over a number of weeks we did this as well. This is all just pooled to show you the averages. You can see in the Verbenone treated ones, the reduction in capture was, well, huge. Down to less than about, let's say on average, about 18, 20 beetles per trap per week. Whereas the controls, we're getting 90, 95 beetles per trap. So it's a good confirmation that the Verbenone is actually inhibiting or repelling the beetles from the attractive source that they would prefer to go to. I said I'd get back to looking at this situation here. You remember in 2021 we had this funny situation where the percent and proportion of damage actually dropped off towards the end of the season here, being very similar to what we saw in the Verbenone treated plots. Overall higher, but just at the end, this couple of weeks, where it was interestingly dropped dramatically so. So I started looking at that and thought, yeah, this might be that fallen berries are more likely to fall. They might be aborted by the plant, or they might just for some reason be more prone to getting knocked out of the tree if there's a wind or something. So I went along and looked at number of fallen berries per square meter under those trees. Counted, I think, 15 trees in control and 15 in the Verbenone plots. And what you see is a huge number of dropped berries, 150 maybe per square meter, right? 140, 150 on average, compared with the Verbenone ones where the numbers dropped to smaller, about 25 per square meter. So it kind of starts to suggest that the trees were more prone to losing ripening berries or ripe ones. In the control plots where you did have higher infestation levels, and perhaps there's some correlation between infestation and abortion of the fruit. The main reason I did that was because this was just a curious situation. You do not see that situation arising much, but I think this is a fairly tenable hypothesis. We can look into that more if anyone's ever interested one day among us. But again, I think it's kind of encouraging to see that if you have Verbenone out there, that you're reducing premature berry drop, which I think could be quite valuable. There's a potential for a little bit of phytotoxicity. These compounds, if you apply them, we did in experiments, we put some out on young branches. This is a bit dark and sorry. You see here's a very young new twig where we made the application here at the base. You can vaguely see the splat. This is the twig I'm looking at, and you can see it's dying off at the end. We looked at what happens if you treat thin branches on a tree directly, other branches on the same tree, and then branches on the tree next door untreated, and look at the proportion of those that have actual dieback, like we see here, and there's no actual statistically significant difference. It looks a little bit like there might be a bit of phytotox on the same tree, but again, it's not statistically different from an untreated tree. So no clarity there. What we suggest for the sake of safety is making the application where I'm pointing with the green arrow down here, on the stump where you've previously stumped the branch, or on mature wood down below. Just do not put it onto young developing branches, because there's that risk of phytotoxicity. Pretty easily avoided though. And when we treated the trees on the base, there'd be no sign of any such effect. So together with the colleagues at Forest Service and Agricultural Research Service, we applied for this special local needs label with the Hawaii Department of Agriculture and Biosecurity, as it's now known, and that's now been issued. This is the special local need label with the registration number down there, valid for 5 years. And it lists the different crops it's labeled for, the different pests you can target, the application rate. You see it addresses a broad range of beetles. These are all bark-boring beetles. Quite effectively. It's been really quite effective in all of these situations where it's been tested. And I'm pretty confident it'll repel black twig borer as well. We don't have any data on that, but I suspect it will work quite well. So again, things available. I'm not sure what the prices are. We can find out more from ISCO when people are interested. All right. So yeah, thanks to Dole guys for letting us work on their lands, and Carl and Angel from USDA for their work, and then supported by CTAHR fund, hatch funds.